Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 5, Lesson 2, Finding the Median, Mode, and Range. In our last lesson, I showed you about how to find a data landmark called the average, or the mean. A landmark is just something that sticks out that you can remember. And scientists and mathematicians use the average or the mean to help them understand the entire set of data points. But those aren't the only landmarks. Today we're going to look at how to find the median, the mode, and the range. So here I have a data set of different lengths. cm stands for centimeters. First thing we'd like you to do when you're given a data set is to get those numbers organized. You can see they're all out of order. It would really help me, though, if I could organize them with the smallest one first and the largest one last, like this. Now we can talk about these data landmarks and figure out what they want us to do. So the median is the word that they give on highways, to this part right in between the two different sides of traffic. And on this picture of one that I found, you can see they put grass in the median on the highway and even planted some trees there. Sometimes it's just a yellow line, but the median goes right down the middle, and that's what median means. So to help myself find it, I'm going to be looking for the number that's right in the middle of the data set. To help me with that, I need to know how many pieces of data I have. 1, 2, 3, 4, 5, 6, 7. Now I have to find the middle of 7. Well, 7 is an odd number. So the close even is either 3 plus 3 or 4 plus 4. I'm going to go with the smaller one. These 3 are on this side. These 3 are on the last side, and the one in the middle right here is 156 centimeters. And so we can say that the median data point for this data set is 156 centimeters. Our next data landmark is the mode. And whenever I think of mode, I think of the character in the Incredibles movie, Edna Mode. She's a fashion designer, and that means that she wants her fashions to be the most popular. Mode means the data point or the number that happens in the data set the most. And so thinking of being the most popular, of all my different numbers here, can you find it? I noticed that 156 happens twice. That one happens the most, so it must be the mode. Our last data landmark is range. And to help me remember this, I always think of the song, Home, Home on the Range. And there's a little picture of that right here. In this case, the song is referring to all of the space where the cattle and the deer and the antelope are playing in the central plains of our country. But that means we've got all that wide open space, and range is a data landmark about space. To find the amount of space, you find the greatest data landmark, or data point, in this case it's 174 centimeters, and you find the least data point, and you subtract them. 4 minus 0 in the single ones place is 4, 7 minus 2 is 5, and 1 minus 1 in the hundreds place is no hundreds. I'm not even going to have it. That means the range, or the big wide distance between the greatest and the least data point, is 54 centimeters. Mathematicians and scientists like all of these different data landmarks because it helps them understand the data set better. So let's see if we can find some of those landmarks in this data set. Hillary counted the number of pencils each of her 18 classmates had. She made a line plot to show the data she collected. Each X represents one classmate. You can see that the title down here is number of pencils, but also knowing what the X stands for is really important to help us do this. So how many classmates had one pencil each? 2. How many classmates had the greatest number of pencils? Well, the greatest number of pencils had by anyone is 7, and 3 classmates had the greatest. We're looking for the mode now. Remember Edna Mode and the most? Which number happens the most? In this case, the tallest stack of X's is for the number 4. So if you were just to find the most popular number of pencils to have and you were a classmate in her room, then it would be 4. Ooh, but now the data will change. A new student joined Hillary's class, and she had 7 pencils. That means we have to add an X to this line plot. That's what it says here. And then we need to think about this. Does this change the mode of the data set? It sure does, because now we have 2 of them. Wow, when I figured out you could have 2 modes, I just thought that was crazy. But check it out. Both 4 and 7 have an equal number of classmates who have that many pencils. So now we would say that the modes are 4 and 7. Here's another line plot for us to consider. Jared took a survey to see how many computer games his classmates have. His results are shown in the line plot. Each X represents one classmate. We need to know the key for this, but we also need to know the title, the number of computer games, and that's what all of these numbers represent. So let's see if we can find some data landmarks out of this data set. The greatest number of computer games Jared's classmates have is, well, this is the largest number right here. So the most anybody has is 7. That's the greatest amount. The least number of computer games his classmates have is 1. He has 0 on his line plot, but nobody chose that one. Everybody seems to have at least 1. Now we can use those 2 numbers to find out the range of the data set. That would be the greatest, which is 7, minus 1, which is the least, and gets us to 6. So the range, the space between the greatest and least data point, is 6. And our last line plot that we will be analyzing for data landmarks has to do with geraniums, which are shown for you right here. The line plot shows the number of flowers each geranium plant had over a month. Each X represents 1 geranium. So how many plants had 6 flowers each? Well, 4 of those plants had 6 flowers. 4 times 6 would equal 24, the total number of flowers that those plants had, showing us that for all these plants over here, they had a total of 24 flowers. How many plants had 7 flowers? Just 1. 1 times 7 equals 7. There were a total of 7 flowers for this plant. How many plants had 8 flowers each? Again, we have 4, and to find the total number of flowers, 4 times 8 equals 32. How many flowers were there altogether? I think I'm going to have to add them all up over here. So let's see. 24 plus 7 plus 32. 7 plus 2 is 9, and 9 plus 4 is 13. I'll regroup that 10 from 13 to the tens place. 1 plus 2 is 3, and 3 plus 3 is 6. So 63 flowers altogether. Now how many plants were there? Well, 1, 2, 3, 4 plants here, plus another 4 here would be a total of 8, and the one more that's in the middle brings us to 9 plants altogether. So now what is the mean number of flowers each geranium plant had? That's as if we picked all 63 flowers and then passed them out evenly to all 9 plants. And I happen to know that 63 divided by 9 equals 7, because 9 times 7 equals 63. So the mean, or the average number of flowers per plant in this month, is 7. And then they ask an interesting question down here. Can you predict the mean just by looking at the data? I just did all the math, but let's take a look at the actual line plot over here. I can tell right away some important things about 7. First of all, I know it's the median because there are 4 on this side and 4 on this side. That's the exact middle value, the middle data point. But also if there are 4 on this side and 4 on this side, and this is in the middle, each one of these geranium plants for 8 could give 1 of their flowers to these geranium plants, and then they would all have 7. So we really want you to know how to do all the math, but we want you to think most about the meaning. Friends, thanks for finding data landmarks with me. Oh, I love playing math with you. Bye-bye for now.